Bismillahirrahmanirrahim. In this lecture, I am solving problem 8.17 from the book Fundamental of Thermodynamics by Bergnacki. So the statement of the problem is: consider the steam power plant in example 6.9 and assume an average T in the line between 1 and 2. Show that this cycle satisfies the inequality of Clausius. So this is very simple. Inequality of Clausius statement is known to us. So we will put the values in inequality of Clausius statement and we will prove that this is correct. So first we use the data from the example 5.9. So from example 6.9. From example 6.9, you can check this data in the example 6.9 in this book. So heat added in the boiler, heat added in the boiler is equal to, is Qn, is basically Qn. Heat added is denoted by Qn, and this is, and from the problem, from the example 6.9 is 2831 kilojoule per kg, and temperature of boiler is equal to 573 Kelvin. This 573 Kelvin is basically available in degree centigrade, but I converted this into Kelvin. Similarly, heat loss in the boiler from example 6.9, Q loss is equal to 21 kilojoule per kg, and temperature average of the line, this is given in our statement to take temperature average. So I think maximum temperature is almost 591 Kelvin, and and second line, there are two line 1 and line 2, and second line is almost less than 560. There is something this value, so average is 568 Kelvin, and this is given in the uh, problem that take the average T in the line between 1 and 2. So this is more than 90 and this is almost 60 or less than 60, but the average is 568 Kelvin. This is the average of line 1 and line 2. Similarly, heat rejected in the condenser, heat rejected in the condenser is equal to, this is from the example 6.9, 2173.3 kilojoule per kg, and temperature of the condenser is equal to 318 Kelvin. All this value is from the example. Now here is show that the cycle satisfies the inequality of Clausius. Required is that the cycle satisfy, show that the cycle satisfy inequality of Clausius statement. So in solution, according to Clausius inequality statement, this is from the book. According to Clausius inequality statement, this statement is basically cyclic integral of del Q divided by T is less than or equal to 0. This is basically second law of thermodynamics. Now we expand this value. See, there are, one is heat added in the boiler and two is heat rejected. So heat added will be positive, heat added in the boiler Qn divided by T, this will be positive, and heat loss divided by T, and heat rejected and the condenser Q rejected and the condenser or Q out or Q rejected and the condenser divided by T. This is basically T of boiler. This is basically temperature of average line, and this is basically temperature rejected and condenser is equal is less than or equal to 0. Now we will put in values in this equation in this statement, and we will prove that this is less than or equal to 0. So Qn is given in example. So this is 2831 kilojoule per kg. Temperature of boiler is 573 Kelvin minus Q loss is 21 kilojoule per kilogram. T average line is 568. This is our assumption. Minus Q heat rejected and the condenser is 2173.3 divided by this is kilojoule per kilogram, and this temperature is 318 Kelvin. Now the answer of this value is 4.9406 kilojoule per kilogram per Kelvin, minus the answer of this value is 0.03697 kilojoule per kilogram per Kelvin, and this is 6.83427 kilojoule per kilogram per Kelvin. So the final answer is minus 1.93 kilojoule per kilogram per Kelvin. So as summation of Q by T is less than 0, so the cycle is the cycle satisfy the Clausius inequality. And this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.